Hello everybody and welcome back to a new video. As you can see, I got my little hard bag. I just wanted to do something very funny today and hope you guys enjoy my heart. Yeah, today we are talking about feature engineering. For those of you guys who watch or who read the last course about feature engineering, you guys know that feature engineering is when you let your business knowledge really shine through. Feature engineering is all about creating new features, selecting new features based on the features that already exist, and just trying to craft and get the perfect features for the model because the model is not going to perform well if the feature engineering steps is not done properly. So really take time to dive deep into feature engineering whenever you work on a data science project and take time to let your knowledge of the business really speak for itself. Because by the end of the day, how can you create the new features if you don't have at least some basic knowledge about um, the topic or what you're working on? And it's not only data science in this case, it's just common sense, it's just business. And if you work for a company, maybe the company is in retail, you have to have a certain knowledge of retail um, to create new features for your project. And so we just want to add that and do proper feature engineering in Python for data science projects. So let's get started. And we see using our cars data set that looks like this after doing all of the data cleaning, data analysis, outlier detections, and everything. It looks like this. So all of the features are there. Make the model, the year, the engine fuel type, the engine HP, the engine cylinders, and again, the target variable is the retail price that is noted as MSRP. And for feature engineering, we've talked about three different steps. The first step is feature creation. So as we say, the goal is to create new features that gives more insights using existing ones. It's all about maybe if you're working in a car data set and you know a bit about how a car works and maybe what feature is going to impact the price of a car, and maybe that feature is not in your data set. Now that you know the name of the features and how to get that feature using the existing features you have in the data set, it's up to you now to create that new features because you know for a fact, based on your knowledge about car, that the feature will be helpful for your model to determine the car price in the end. And this is really all about letting your business knowledge shine through. And again, for this for this cars data set, we have created a power to cylinder ratio, which is pretty much the engine HP divided by the engine cylinder. This is a way to understand better the performance across different cars, and this is significantly changing the price of cars based on the power to cylinder ratio. We do not have that feature in the data set. However, we have two other features uh, that we're able to use and create that feature from the data set and exactly what we're doing right here. Look at how the result is, and the next feature will be now the features have been added to the data set. You see that we've added a new feature. Before that, if you looked at what we had only popularity MSRP. Now we've added a new feature from the data set, power to cylinder ratio. That is how you actually create a new feature. You create a new feature and you add it to your data set, and this is how you pretty much do it. And the next step will be feature transformation, as we talked about. Sometimes you have a feature that for you is significant for your model, and you want to add that feature in your data set, in your model inside for your data set. However, the way human understand language, computers understand only numbers. So it could be float integer, but computers does not understand any sort of text language or anything. No. So if you want to feed that data into your model, you have to find a way to encode those text data set into numbers. That will make sense in the end. So it doesn't just have to be any numbers, doesn't just have to be any sort of transformation. It has to be a type of transformation that will let the model understand what that feature was meant to do. And so when we were talking about that, we were talking about the transmission type of the data set, which is something people really look at when they purchase a car. It could be automatic, it could be manual. Me personally, I purchased automatic car because I don't really know how to drive a manual car with all of the functionalities. I'm not really into that. So I prefer a car that is automatic. And me, because I prefer a car that is automatic, the price is also going to change based on that. And so the way we do that is to do the one-hot encoding and using this function p0.getDummy. So that function is also in the course, so you guys can just um, copy and paste that. And if you want to learn more about the p0.getDummy, let me know. I can explain a bit more about that. But it's just a way to encode or transform some categorical type of variable into numerical one. Basically, it's creating a set of new features that are binary, and each feature is talking about one category of the feature. In our case, since we have the transmission type, and the transmission type has five categories, it could be manual, automatic, and there's two other features I probably didn't know about. I forgot. But for each feature, this PDA.getDummy is creating another feature from the data set. That feature, maybe the first feature is for automatic transmission type. That automatic transmission type feature will give one to all of the cars that have a transmission type as automatic and zero otherwise. It's going to create another feature for manual where the values are one for all of the cars where transmission car is equals manual and zero otherwise. It's creating as many features as the number of categories you have in your original features, and those features are going to be binary based on if the car has that type of transmission type, or if the car does not have that. And so once you do that, you end up with something that looks like this. So after creating power to cylinder ratio, you create now the first transmission type, which is automated manual, and it's kind of giving zero to all of the cars where transmission type is not automated manual. That's why you see zero here. Now, if you jump into case, we have one, two, three, four, five new features because the category featured transmission type has five categories. And then now you look at here, you see transmission type 111. One just means that this car BMW has a transmission type manual, and you can see that manual, 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 manual. That's why you see one. And wherever the transmission type is not manual, it's going to give zero. This is why you see all of the zero, 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 zero. So remember, by the end of the day, those features are binary, and it's a way to tell the computer, okay, I'm creating these new features, and whenever the transmission type is automatic, you give it one. When it's not automatic, you give it zero. And this is a language that the computer understands. The computer does not understand this, not at all. It will be like, no, it would be like a dog in front of a TV, not really knowing what is going on. And you have to find a way to tell the computer what you want and what you want to do for your model. And that is about feature transformation. There's so many ways to do feature transformation, but I think that's like the basic way to start. And once you get to understand that in details, you can explore more and more way of feature transformation. And again, if you have any questions, just let me know. And the last way is feature selection. This is just a good way to like select only a handful features for your model, because by the end of the day, you do not want to use all of the features. Maybe sometimes you do have to use all of the features, but when the data set has too many features, you want to find a way to select only the features that you need for the model. And like in this case, for our data set, we already are ending up with 21 columns. Taking off the target variable, it's 20 columns and it's 20 features. Maybe we don't want to use all of those features. We need to find a way to select only the most important feature for the data set. It's not going to be done randomly. It's gonna be, it's like a process, it's a mechanism, it's just like a way to do it. And how do you know if a feature is important for the target variable? It really depends. A feature is important for the target variable if that feature explains the variability of the target variable. Maybe the feature is showing when you add that feature into your model, it's really showing you how car price change based on that feature. And this is what we want. We don't want a type of feature where you add that feature and it's not really changing anything for car prices. We want a type of feature that is when you change value of the feature, the car price is also changing. When you change the value of the feature, the car price is also changing. That is explaining how the variability of the target variable is. And here we're just dealing with the target variable. And so, how do we do feature selection in Python? It really depends on if the features are numerical or categorical. But since our target variable is categorical, we can evaluate the importance of each numerical features to the target variable using what we call the correlation matrix. The correlation matrix is just a matrix that gives a score from 0 to 1, where 0 means a score from -1 to 1, where -1 means it's highly correlated, but in the negative way. 1 means it's highly correlated in the positive way, and 0 means kind of neutral correlation. And we want to achieve like those high correlation close to 1. If a feature is correlated to the target variable with a value of maybe 0.75, that is a good sign that, okay, this feature is important and we need to keep that for the model. And exactly as you do, we kind of use the function for feature importance. We use those correlation, and we only focus on the target variable, which is the mean score, and we ended up with this correlation matrix. So this matrix is giving a score from 1 to 0 from the highest to the lowest value. And you can see that the score for 1 means MSRP is highly correlated to MSRP, obviously. And some of those features that are highly correlated to MSRP are the engine HP, the engine cylinders, and the power to cylinder ratio, which is higher value is 65, 0.65, 0.55, 0.35, the transmission type, automated manual, the year of the car, which is something that we were expecting, and kind of the features after that just not highly correlated. Good thing is the feature that we've created, power to cylinder ratio, is actually having a pretty strong correlation with the retail price, and it's something that we wanted to achieve. Using the existing one, creating new features, and adding more insight into your model. Now we're going to be using this because we see that the feature that we've created makes sense and above all is still based on your knowledge of the domain. Um, and if you want to analyze the feature importance of a categorical variable with the target variable that is numerical, you can use some visualization and some plots if there are some like trend that are going up, down, up, down, up, down. We can start thinking that maybe this feature is actually really explaining the variability of car price, and you can do that using some data visualization. I will give that to you as an assignment because you guys already know how to do some data visualization. But again, if you have any questions, let me know. And once you do that, in the end, you can just select a handful of features for the model. Maybe that's just an example of how you can just select a few features from the model. Like here, you select the make, the model, the year, the engine HP, the engine cylinder, the power to cylinder ratio, the transmission automatic, popularity, and MSRP. You continue on with those selected features for the model. And this is really how you perform like a simple feature engineering. Sometimes based on the knowledge of your domain and sometimes the problem that you're solving, you can go further with feature engineering and sometimes can just not doing anything at all. And so it's really up to what problem you're solving, what are you trying to achieve, how many features you have in your data set. Sometimes you don't have to do any sort of feature engineering because all of the features you have are already very important for the model and you don't have to select some new features. You take all of the data so you continue on with that. It's all based on that, but this is how you can perform with basic feature engineering and explain the steps with your stakeholder. And that's it for today. I hope you guys learned something. And if you have any questions, as I said, let me know. Uh, I have my email and, see you soon. Keep learning, keep exploring, and, keep working on this science project. See you. Bye. Have a good day.